Okay, so we have already finished the first two topics, which are definite integral and indefinite integral. Next topic is integration by substitution. But before we move on to that, we're going to have a very brief discussion about why do we need integration and what's its purpose. Now, this is not necessarily part of your syllabus, and it's not something that I'm going to quiz you on during your exams, but it's still good to know what exactly is happening. So for example, we have this function right here. We integrate it and we get this number right here. We got 28/3 if my calculation was correct. Maybe it wasn't. But what does this number 28/3 tell us about this function x cubed plus 2x squared? And so what it does, it's very interesting. So suppose, let me draw a diagram. So we have this right here. So as always, we have x here. We have y here. And suppose we have a function that looks something like this, okay? It can look like anything. This is just a function that I have decided to draw. And of course, this is y is equal to fx. What integration allows us to do is calculate the area underneath this curve, okay? So, suppose we want to calculate the area in this range. We want to calculate this area, okay? How would we do that? Suppose this is 5, this is 7, okay? So what we do then is we integrate fx with respect to x inside the range 5 and 7. And that gives us the area that I have just marked out. That's what integration is. So let me erase this. Oh, erase the curve as well. Okay, I'll just try it again. Suppose now, excuse me, we want to calculate this area, okay? When x is equal to 2, and over here, suppose x is equal to 5. And we want to calculate this and this area. What would we do? First, we need to find this spot. Suppose this is 3, this is 2, this is 5. And then what we are going to do is we're going to do this twice, okay? Because notice that this will be a positive area and this will be a negative area. And so what we will have to do is we will have to integrate fx with respect to dx within the range 2 and 3. We are also going to integrate the area fx dx within 3 and 5, but this is going to be negative. So what we are going to do is we are going to multiply this with a minus. And so minus and minus will become plus. And once we've done that, we will know the area of the shaded region. Okay? And that's effectively what integration is. And we can use integration to do a lot of other things, but at this level, what we are going to do is this really. So that's the difference between, also the difference between definite and indefinite integral. When we are doing indefinite integration, we are just finding out an expression. But when we plug in this range, we actually calculate the area. underneath the curve. Okay, so once again, this is not necessarily part of your syllabus. I'm not going to ask you to draw a diagram and find area under a curve in a range, but it helps to know exactly what you are doing. And maybe you will end up using it somewhere else in some other course